So today we will be studying about differentiation.
Yes.
Differentiation is nothing but the rate of change.
Mhm.
For example, if you have a y function, if you have to differentiate it with respect to x, we write it dy by dx. This is the way to represent the differentiation sign. Dy by dx means you're differentiating the function with respect to x.
Okay.
If it is dy by dt, it means you're differentiating with respect to t. Whatever is the denominator, it depends upon the denominator with respect to what you're differentiating. Here you are differentiating with respect to x. Here you are differentiating the function with respect to t. Okay, so let us do some differentiation formulas. The first one is differentiation of x to the power n. If you have x to the power n and you have to differentiate it, the differentiation for x to the power n is nx to the power n minus 1. Is that okay?
Okay.
The differentiation of x
Yes.
to the power n is nx to the power of n minus 1.
Yes.
Some examples. Let us take some example. You have to differentiate x cube. So if you apply the same, what will I say? 3 comes at the front, x to the
X
power
squared.
3 minus 1. So you will
Mhm.
say the differentiation of x cube is 3x cube.
Yeah. I learned some basic differentiations already, but we're going over differentiation with logarithmic functions mainly now. Like,
Okay.
mhm.
Okay, I will quickly then move on. Just quickly. Okay.
Okay.
So differentiation of any constant function. What is the differentiation of constant? It will be
Let's see.
0. That's
Mhm.
right. Differentiation of exponential function. What is the differentiation of e to the power x? It remains the
Uh,
same,
yeah.
e to the power x.
Mhm.
Differentiation of log x or ln x. First of all, let us say ln x. What is the differentiation? It is
I mean,
by
1 by x.
yeah. So this is and further differentiation. Have you studied about the trigonometric functions also?
No, we haven't done that yet.
Okay, then we can skip for the timing. So let's concentrate over the logarithmic functions. As you want to do the logarithmic, so we can study the logarithmic functions. Okay, you have been given y is equal to log 1 plus 3x. When it is written log 1 plus 3x, it's self-understood that the base is e. Okay, so it won't be mentioned given to you in the question. If it is given log of 1 plus 3x or ln of 1 plus 3x, it means one and the same thing, unless the base is given to you. Do you get it?
Okay. Yes.
Means if you have been given a question log of 1 plus 3x, it's just ln 1 plus 3x. You have to treat it just the same, ln of 1 plus 3x. So you have to find out dy by dx. So what will be the differentiation of this? I know that differentiation of log function is the reciprocal of whatever is the term. So it will be
Yes.
1 upon 1 plus 3x. That's fine.
Yes.
But you have to differentiate the term in the bracket also. You haven't
Mhm.
differentiated this term. So multiply by differentiation of 1 plus 3x. Is it okay?
Yes.
So that would give me 1 upon 1 plus 3x, and differentiation of 1 is 0 and differentiation of 3x is 3. So your final answer is 3 upon 1 plus 3x. Have you got it?
Yeah. Yes.
Okay, so let's move on. Let's try another one. The question says y is equal to log of x cube. Log of x cube. So there are two ways in doing this. If you know the log properties, if I know the log properties, you can apply the log property. Else, if you don't know the log properties, just apply as we done in the previous part. If I apply the log property, 3 can be taken at the front. When this is the property of log, 3 comes at the front and your expression becomes 3 log x. Is that okay?
Yes.
Now you differentiate it. The differentiation of this is simple. dy by dx, if you have to find out. 3 is a constant term. Log x differentiation is 1 by x. So your final answer is 3 by x.
Yes.
Unless if you don't know the property, then also we can apply the same way. Log x cube, I know that it will be 1 upon x cube multiply by differentiation of x cube. 1 upon x cube multiply by differentiation of x cube is 3x cube. If you solve it, it is nothing but one and the same, 3 by x. So you can go by any of the way.
Yeah. Does the basis matter at all when you're doing this?
Does
The base for a logarithmic function doesn't matter? Like, does it change the answer at all if there is a base of like 5 compared to 10?
if it is particularly mentioned in the question, the base is 10, then the answer will vary. If it
Okay.
is particularly mentioned, for example, if it is just given log x, then we just treat that the base is e, which means ln x only. Let me explain that. If it is given log x or it is given ln x, it is treated as it is actually treated as same, because the base is actually e and both are equal, both are same. But in case you have been given a different base, log x to the base 10, and you have to differentiate it, so this differentiation of this won't be 1 by x. Okay, in this case, what I will be doing, if you have to differentiate log x to the base 10, so in this, first of all, you will apply the log property.
Yes. Yes.
Log property, what does the log property says? Log property says that I will just write it as log x divided by log 10.
Yeah.
Is that okay?
Yes.
I will just write it in this way. Now, log 10 is a constant, so that can be written outside of the bracket. And log x, now you can differentiate the log x, which will be 1 by x. So in that case, your answer will be 1 by x log 10.
Okay.
Is it okay?
Yes.
So it depends upon the base. And if base is not mentioned, we treat it that the base is e, and we just, the differentiation will be 1 by x only.
Okay.
So further moving on, the question is, you have, okay, let's fill y is equal to ln x e to the power x. Ln x e to the power x. Here there is another property which you have to apply for the logarithm
Okay.
test.